Hi everyone, thank you for joining today's presentation entitled Cloud Security Principles and Practices. Before we get started, I'd like to review a few housekeeping items and let you know how you can participate in the session. We are recording today's presentation and will forward a link via email when it's available on our website. At the end of the presentation, we'll do a Q&A session. You may send us your questions through the question window in WebEx. If at any point during the presentation you run into technical difficulties, you may send us a chat via the chat window. Please send your comments to host and presenter. Okay, let's get started. I'd like to introduce Joan Pepin, Director of Security at Sumo Logic. Joan is a 15-year information security veteran with experience in a variety of industries spanning technical, operational, and management levels of security. She is the inventor of SecureWorks anomaly detection engine and event linking technologies. Her specialties include policy management, security metrics, incident response, and security thought leadership. Joan has been a speaker at Forrester and Gartner Security Summits, and we're pleased she could join us today.
Good morning, everybody, or afternoon if you're in the other half of the country. Today I'm going to talk a little bit about some cloud security best practices and some design principles. The reason I'm here is I really believe that the cloud is an opportunity to simplify and increase your security, despite any of the hype or FUD that you might have, that you might have heard out there. And I'm actually sort of a true believer and an evangelist of cloud security, so I'm happy to be here to talk to all of you about this today. And so let's get started. So first off, I'm going to be talking about security in the public cloud and building an infrastructure and deployment, a service in one of the public cloud providers. Here at Sumo Logic, we are proud users of Amazon Web Services, but a lot of what I'm going to talk about is also perfectly applicable to Rackspace or Windows Azure or any of the other public utility model clouds that are starting to come out these days. We use Amazon Web Services specifically because of a lot of the scalability, auto-scaling features, and a lot of the extra security features that AWS provides. But as I said, this is going to be generally applicable because we're going to talk about some high-level principles and practices. So some things that I think the public cloud is actually an opportunity to simplify and increase security. And I believe that this is largely misunderstood for a number of reasons. One of which being that security people in general, right, we tend to be a little conservative. We want to really understand all the technologies that are in our jurisdiction and our purview to make sure that they are as secure as possibly can be. And, I've been accused sometimes myself of being a control freak, and I think that applies to a lot of us and simply the way that we operate. And so the idea of handing over your infrastructure to a third party such as Amazon can be frightening and can often actually elicit, what I would consider to be a bit of an emotional reaction. So I want to take some time today to sort of break that down and talk about what the actual risks are and more talk about how you can sort of judo this whole thing around and turn the cloud into an advantage from your security perspective. So, first off, I want to mention that my view of the public cloud is the same as any public utility, right? Public utilities are often disruptors in the business world, right? If we think back to, Thomas Edison and when, the electrical grid first came online, that was a huge disruptor to the business world. We then have, the telegraph and telephone systems, and even, when we go back to the fax machine and what people actually called the fax network, these were all business disruptors that all introduced their own security concerns, right, about confidential data. Fax spam was a problem long before we had email and email spam. The internet, of course, another public utility model, which has been a huge disruptor. And now we come up with virtualization and cloud technologies. And this is just yet another wave of technological disruptors that we need to understand and integrate from a security perspective. And I really do believe that the economies of scale and the basic economics of the cloud that are bringing everybody there are just as applicable to the IT security crowd as they are to the bean counters and the operations people and everybody else who's pulling us there. Basically, the economics of the cloud are inevitable. And that's the way, clearly, that many services in business are going. So as a security professional, I think it's very important that we take some time to understand what it is the cloud is and what the advantages and what the actual risk models are. So in order to compare and contrast, I'm going to talk a little bit about the old world, right? So, you have people on your staff who frankly know black magic, right? If you're running in a data center, if you have a tech ops staff, they need to know things about raised floors and BTUs per square foot and cooling systems and wattage and all of that stuff that I used to be deeply steeped in. And all of those things are very specific skills, and they have nothing to do with running your service the way that you want to run your service. They have nothing to do with securing your service. That's simply keeping the infrastructure up and running, right? Ping, power, and pipe. So that black magic can be limiting, right? Because you force yourself to think within the boundaries of that data center, right? You've only got so much spinning disk. You only have so much RAM. You only have so much CPU. There's only so much bandwidth to the data center. And so this limits your thinking and forces you into a box. If you force yourself to work within those boundaries, you're going to make sacrifices in order to fit within that infrastructure. And you're going to find yourself worrying about how your new service or how your new business model may affect the capacity of what you've already got. I would love to bring this new service online that the developers have come up with, but I'm not sure that my firewall that's only 18 months into its 36-month refresh cycle has actually the computrons that it needs in order to open up and run this service. So that's some of the limitations that we have in the old data center world. And these are some of the limitations that are bringing the tech ops people and bringing the business people into the cloud. And I believe that they apply just as much to the security side of the infrastructure as they do to the rest of the service and infrastructure. And so where does that situation leave you? Well, it leaves you trying to insert yourself in the process run by the ping, power, and pipe guys, and it leaves you divided. It leaves you, hemmed in and locked down, constrained by, rapidly obsoleting static resources, right? So you've got to worry about the security of your code, of your actual offering, your service. You've got to worry about the physical security of your data center. Even if you're hosting at a place like Exodus or L3 or something like that, you still have to worry about your physical architecture and configuration. And once again, how much spinning disk you have, what's the strength of your CPUs. Has somebody accidentally, plugged in a crossover cable someplace where they shouldn't? What is your VLAN configuration? Do you have span ports that you need in order to run your IDS devices and your web app firewalls and all of those things? Having come out of working for a managed security service provider for nearly 10 years, you'd be amazed how often a span port on a switch was something that prevented a major operation from being able to install something like an intrusion prevention or intrusion detection device simply because their Cisco switch did not have the capacity to add another span port. That could delay a project that was critical to the business, like an intrusion prevention device, for 18 to 24 months. These are things that you do not have to consider in a cloud deployment, right? Because now you're dealing with these legacy compromises, and that might or might not have been a good idea at the time, but your service is evolving and your business is evolving and your customers have new needs that your hardware and your static configuration might not be able to meet. And frankly, maybe it never did meet it because of, once again, the cost compromises and the limitations of the data center environment. And we do lots of things in this business where we transit public space. And we take steps to secure that transit, right? We use the internet, we use the telephone network, and we have best practices that allow us to securely use the internet. When the internet was first, starting to become public in, the early 90s, I remember there was a lot of trepidation about businesses, going on. I was involved in one of the first e-commerce sites that took credit cards over the internet, and that was a real huge deal. And now, of course, we think nothing of it. And I'm certain that the cloud and cloud security is headed in that same direction. So now we'll talk a little bit about the new world. Cloud computing is a completely different paradigm. When I first got here about 20 months ago, it was a culture shock. There was definitely a learning curve around this paradigm and how to operate in the cloud because it's very different from the data center-centric view of the world. And I include hosting in that as well. The cloud it is and it is not hosting. in one sense, we are hosted in Amazon is one way to look at it. There are a bunch of physical servers there that are running our virtual machines, that are running our deployment, and that's a hosted model. But the abstraction layer and the tools and the APIs provided by that infrastructure provider allow for so much more than if we were simply hosted in an Exodus, for instance. So some of the things that, the trade-offs that you make, some of the learning curve that you're going to encounter is, giving up that precise control over exactly which servers and host names and such. And we're going to trade that for statistical models and statistical control. So, I'm no longer going to worry if this particular box is always running, 5 nines. I'm going to worry that I have a box running always at 5 nines, right? The scripts and capacity planning spreadsheets that you have to deal with manually now can be replaced by code, feedback loops, and auto-scaling. Your 36-month hardware refresh cycles can be replaced by, for instance, in the Amazon world, making bids on excess capacity, setting your own price and buying compute by the hour at a price that you set when Amazon has the excess. It's a very, very different model than what you're used to right now. And you're going to give up that physical control, being able to reach in and touch your hardware for control over your process, control over your automation, and most importantly, control over your design. Okay, but, I've heard a lot of scary things, right? And I know, for instance, that there are some major corporations out there that have policies in place that simply state, we will put no data in the public cloud. What I don't see behind any of those policies is an actual risk model, is any actual risk assessment. I've heard, very little in the way of how hosting in Exodus, for instance, is so much more secure than hosting in Amazon. There is the argument, of course, about what an Amazon employee could do, but you can make the same argument about what an Exodus employee could do. In the end, we have to trust our vendors. We have to trust our hardware vendors that they aren't creeping things into the BIOS. We have to trust our internet service providers that they're not doing bad things with our traffic. And that's where certifications and due diligence come in. So if we're looking for control, what I'm saying is we can take that game to another level and play a different game. And I'm going to give sort of a visceral analogy. If you think about someone out on the street playing 3-card money, right, that's a service they're providing. They're trying to make money. They're providing some entertainment. And there's a certain way that you run 3-card money, and it's all about precise control. It's about knowing exactly which card is where, knowing what you've got palmed, having a couple of shills in the audience to set things your way. And you're able then to manipulate your circumstances in a secure manner in order to achieve the desired result of taking people's money. Now, that's one way to operate, but it's certainly not scalable. If you think about the same model of providing entertainment and taking people's money, we can now talk about a casino that operates on an entirely different premise, on the more cloud-based premise, on a statistical premise, that the house will always win. They don't have exact, precise control over which blackjack dealer is going to have a rough night or which machine is exactly going to pay out how much. The Gambling Commission won't let them have that control. But they have the casino set up in such a way that they know, statistically speaking, they're always going to win. And that, I believe, is really the way to design a truly secure and highly available service in the cloud. As one of my favorite thinkers and authors, Sun Tzu, said, the highest form of generalship is to thwart your enemy's plans. Thwarting him on the battlefield was considered to be much less skillful than actually defeating your enemy at the level of his strategy. And so that's what we're talking about in terms of cloud security and cloud design. So this has all been, kind of theoretical. So, what's really in it for you, right? What can you do? Well, how about not needing to regularly review your firewall rule ordering as part of your operational process, right? Worry about the size of your checkpoint objects and what order your rules are in, and whether or not that server that's, in a rule somewhere near the top of the policy is even still in existence. So you have to buy, in addition to your firewall, you have to buy something like a skybox that tells you even if you're still using the rules that you need. And this becomes a major operational overhead in a lot of enterprises, is simply just dealing with that. And what I'm saying is, in a cloud deployment with a cloud service, that's something you never need to think about again. Because what you'll do is instrument your deployment, gather that data, You design the rules on the whiteboard in such a way that makes sense and are performant. You deploy, and then you iterate that from the whiteboard, not from a live firewall console. So that's just one example of what we can achieve in the cloud by exploiting your own system thinking strengths, right? It is security people who best know how to break a system, best know how systems interoperate and where the nooks and crannies are. And by laying that all out from a design perspective and working from the top down, when all of your infrastructure is actually code, you're able to apply those strengths and apply that control in a way that's going to benefit you from a security perspective. And so that really all comes down to design, right? Design, design, design. Because every layer of connectivity is now in your software. Every firewall, every IDS sensor, every configuration file is all in your code because your code is the entire system. You know, yes, at the end of the day, there are virtual machines, but they're created, monitored, and destroyed by the software you write leveraging your infrastructure provider's APIs. So the answer to security in this environment is an SDLC, is a secure development lifecycle. And going where, you know, some of us fear to tread, which is right into that secure development lifecycle, interacting directly with the architects and developers who are building the services that you're deploying. So, you know, if you engineer security into your application, it sort of had to weave its way through the application, right? But it stops where that meets the infrastructure, because once again, that infrastructure is static. It has crossover cables and span ports and things like that to worry about. Whereas all of that, when it's in your code, is much easier for you to manipulate, is much easier for you to control the design of. It's much easier for you to set the standards and specifications and testing methodologies that will allow for this to be within your security standards and what you consider to be your threat model. So in order to design or build any of these things, you've got your basic building blocks, right? You've got your primitives. And these primitives are going to be the same in, you know, in any of these systems, right? You've got your I/O, memory, storage, CPU, your code. You've got data. Your data is going to be at rest, in motion, or in use. You've got access control. You've got to worry about your monitoring tools, third-party apps, troubleshooting tools. And you've got your interfaces and APIs. And what I'm saying is to back up a little bit and put these things out on the whiteboard and think about them from a high level. All of these things should be compartmentalized. All of them should have well-defined inputs and outputs. Everywhere where these things can be encrypted, they should be encrypted. Everything that can be validated should be validated. Input validation, output validation. Everything needs to be made subject to access control and AAA. Everything needs to be rigorously tested, code reviewed. And when you lay it out in that manner, it becomes relatively simple in that each and every one of those primitives needs to be thought of on its own and in combination with the other components it interacts with. It's really that simple and that complicated. Because simplicity leads to security. You know, that's a well-understood argument. The more complex a system it is, the more easy it is to break. The more failure modes and state changes a system has, the more likely it is to break. So the simplicity of your design, of your interfaces, and your data flow will all help lead to a secure and scalable system ultimately that will minimize your attack surfaces and minimize your moving parts, both figuratively and literally. What you want to do is keep the inputs and outputs of each of these components well-defined so that anything out of your spec can simply be scrubbed by an IPS device, by a firewall, or simply by the code that you are yourself writing. Scrub all of your input and your output. Output sanitization is an interesting concept that I sort of, you know, learned about here at Sumo Logic, because we are consuming our customers' log data and feeding that back to them on their screen. If we, for instance, were to show malicious URLs and whatnot back into, if someone were to inject JavaScript into their log files, we certainly don't want that to be coming back through our browser on the other side and making bad things happen to our users. So we worry about not only about input sanitization, but output sanitization. And so that every component along the chain that the data flows through worries about what kind of data it's allowed to accept and what kind of data it's allowed to put out. So we don't ever trust the client-side verification, right? We engage in it, but we also have that same verification on the back end as the data moves through the system so that you're able to create that defense-in-depth layered security approach. So basically, if you have input, you sanitize it. If you have storage, network, or memory, you encrypt it where you can. It's that simple and it's that complicated. The way to get there is to understand everything that you're using, understand everything that's within your purview. Know which VMs need to run which services and what ports those services run on. Know which nodes need to talk to which other nodes. Know which of your users and services run, know which users your services run as, and know what their permissions are. Know what data structures your components accept and what data structures they return. And understand what very rare data needs to be kept in permanent storage versus in your code base. Because, for instance, your firewall rules, your intrusion detection policies, your file integrity checker policies, all of these types of things can be VTL templates, velocity templates that are in your code that builds your deployment. You don't need to worry about maintaining one particular static lives forever hard drive that you have to take these backups of just to have your configuration files in place. Those configuration files should be generated automatically by the code that you've written to leverage your infrastructure provider. This allows you to understand your state changes. This allows you to understand everything that happens in your deployment. And having that complete understanding of your infrastructure and of your code, because they're one, allows you to achieve a level of security that I don't believe is nearly as simple to achieve in a data center environment. Actually putting this into practice and leveraging these things requires automation. And with that automation, all of these things are possible because your entire infrastructure is your code base. The things that I dreamed about, when I worked in a data center environment are possible to me now, right? For instance, running file integrity checkers absolutely everywhere, running an IDS on every single node, running a host-level firewall on every single node. All of these things would have been very difficult. And those 122-point checklists that you required in order to bring up a new node and harden it and make sure that it was secured and met your policy, those things are now reproducible in unit-tested software. There's a big difference between system administration and software engineering. System administration is a very reactive discipline. You have to get in there and respond to failures. You have to have someone sort of doing what we used to call manual intervention, or what I would call cowboying, right? And when you move into a world of pure code, you're now talking about software that by its nature does the same thing every single time. So you can eliminate a lot of that human error. A lot of that component becomes irrelevant because we code these things now. So for instance, we're undergoing a PCI DSS service provider level 1 audit here at Sumo Logic, and we're working with our partners over at Brightline CPAs and Associates for a number of different certifications. And as we're going through the PCI standard, we've had to put in place what we call a lot of mitigating controls, because the standard is written in an old-fashioned way that assumes you're in a data center, and it wants to see, for instance, they wanted to see that 122-point checklist that we use on every single box before we bring it up, that the system administrator is supposed to check off. Well, we don't have that because we don't have a human being who brings these boxes and puts them online. We have code that does that. So actually, I had to, provide our auditor with a chunk of our source code to show him these are the steps that are automatically taken on each and every single node in our deployment without fail. And if there is a failure, that generates an exception that we catch, and we simply spin up another box with that configuration. So all of these things that we are so tied to, we're so tied to, in fact, that the standards are written around them. Our auditor wanted to know, see a picture of our DMZ. Well, we don't exactly have a DMZ. We have a number of clusters, and each node is only allowed to speak to the other nodes on the exact ports that it needs to speak to. Everything is firewalled. There's firewalls on the front end, there's firewalls on the back end, and then there's a firewall in each and every individual node. In addition to that, we leverage the Amazon Security Group's feature, which is a virtual firewall that they operate. This, in a traditional manner, creates an extremely complex network diagram, and we had to do a little work with our auditor to get through that and make these things apply to the standard. But what we heard over and over and over again was that this was no problem because it exceeded the security of the standard. right? Anything that you do that does not exactly meet the standard simply needs to exceed the security. And over and over and over again, after we go through hundreds and hundreds of controls, that's what I keep hearing. We have exceeded the security of the standard by doing it this way. And that, I believe, is really the key. We can exceed, and you can exceed, the security of the basic standards that we all operate by leveraging this automation, by leveraging your infrastructure providers in a way that you're just not able to do in a traditional data center. So like what? I'm going to talk about some of the things that we actually do here at Sumo to leverage this, right? So one of the cool things we do is, as all of our virtual machines boot up, they register themselves with a central messaging server. Let us know what kind of node they are, what IP address they own, what services they're running, and what ports they need to talk to. We use that central messaging server then to add these servers to the queue, and that will then dynamically configure our security groups and firewall rules in order to allow that new node into the deployment. So this is something that can happen automatically in the middle of the night. Nodes can come up, nodes can go down, and this is not something that a systems administrator ever even needs to worry about, except maybe read the report in the morning of what happened overnight. We're able to automatically build these firewall policies, based on all of the tags that we use for these instances. We're able to, for instance, when we remove an instance, or an instance is automatically removed, if that has a permanent storage on it, which very few of our nodes do, we only use permanent storage wherever absolutely necessary. Usually our stuff is ephemeral. This is another cool thing. We boot up an ephemeral instance, something that's just going to disappear back into the ether when we're done with it. We encrypt its hard drive with a key that we keep in memory. I don't know the key. Nobody at Sumo knows the key. It's in memory. When that device goes away, that key goes with it, and that data is gone forever because it's encrypted with a key that no longer exists. In the cases where we do keep actual data on a spinning disk, for more than one reboot, when that node is permanently decommissioned, either manually or through code, that node is tagged as having sensitive data that needs to be scrubbed. Every 15 minutes, we have a scrubber bot that runs through all of our instances and checks their tags looking for the scrub me tag. Anything that it finds with the scrub me tag, it mounts on a separate volume and runs a DoD level 5 times overwrite to completely make sure that all of the data is destroyed according to DoD protocols, which is one of the Amazon best practices that they recommend. So these are the types of things, once again, that can be very difficult to achieve and time-consuming and expensive in a traditional data center environment. We're able to do that with very little to no human intervention. We're able to run host intrusion detection and host firewalls and host integrity file checkers on each and every single node. And those firewall rules, those IDS policies, and those file integrity checker policies are all based on exactly what job that node is doing at that point in time based on the tags that it boots up with. We're able to unit test and security test everything in separate deployments without needing new hardware, without needing a separate data center to run it in. Simply, our developers all have the power to boot up a copy of production that is completely physically isolated from production that will have no effect on it. They're able to boot that up, do security testing, do reliability and availability testing, and tear it down in an hour or two when they're done, incurring very minimal costs to Sumo Logic as a result. This allows our security to really keep pace with our product. Another key is to encrypt everything, like we do on the internet, right? Everything is encrypted end-to-end. It's encrypted in transit, and it's encrypted at rest. We've been exploring some third-party technologies. I've talked to a number of people over the last 2 years who claim to be able to do encryption while in use, and that's certainly still a burgeoning technology that is not quite ready for prime time. But it's a very interesting area of research, and I think that we're going to be there in a couple of years, at least in certain use cases. I like to tell a story about the messenger, about encryption, right? How we have been doing business in dangerous environments with sensitive data for a very long time. If we think back thousands of years onto an ancient battlefield, and you've got two generals looking at each other from across the field, and the general decides that one of his commanders needs a particular message. Well, he would pull out his secret encoder ring and pull out a piece of papyrus, and he would encode the message to his commander on that papyrus and fold it up and put a wax seal on it. That was his authentication. That was his identity validation. Hand that to a messenger. That messenger would run across the battlefield, hand that to the commander, who would validate the seal, break the seal, pull out his decoder ring, read the message, and then cut the messenger's head off, right? And that's basically the same way that we treat our nodes. That's the same way that we treat our message queues. That's the same way that we treat all of our data. It's the same way that we've been handling sensitive data in open environments for thousands and thousands of years. Encryption. All of this allows you to get to what I call the default deny Nirvana, right? Some of you might be familiar with a sort of a famous blog post written by the security researcher Marcus Rainham a number of years ago where, he sort of proclaimed that if you're not default deny everything and only whitelisting your connections, then you're doing it all wrong. And a lot of people were very upset because they said, well, there's no way in a realistic environment that you can actually achieve that. We have actually achieved that, and it's very simple. In fact, now that we've done it, I can't think of any other way to live and operate. Only expected connections from expected users running expected services are allowed, period. The only thing in our Sumo Logic service that has any connection with the actual open internet is our load balancers, which are actually run by Amazon. We're available on service.sumologic.com on port 443, and if you're sending data to us, we're available on collectors.sumologic.com on port 443. And that's it. Everything else is firewalled, security grouped, broken off, and segmented in such a way that nothing can get to anything. We can't SSH from one of our boxes to another. That all has to come from a central point. If we're running something like HDFS, which we no longer are, but when we were, the HDFS ports were the only ports allowed in and out of those boxes, that and port 22 from our central jump server. So these types of things that we have always wanted to achieve in a data center environment, and often we're not able to for lots of the legacy compromises and physical reasons I've discussed, are now a part of my daily reality. And I feel much more confident and secure in our deployment the way that we've designed it than I have anywhere else that I've worked, and that includes working, for defense contractors. So, in conclusion, I really believe that the public utility model of cloud computing brings substantial advantages of scalability and automation which can be leveraged by the information security professional, not just the bean counters, not just the tech ops people, but you, the security professional, can make the same use of these same economies of scale and automation that make the cloud so attractive to everybody else. And as a result, your service can be more secure, built on the public cloud for less investment than in a traditional data center. Just have to remember your fundamentals and always shoot your messenger.
Thanks, Joan. So we'll open up to the Q&A. If you have a question that you'd like to submit, you can send it to us via the Q&A window within WebEx. Here's a question. Joan, what are some of the top security mistakes that you see when organizations build services in the cloud?
So, the biggest mistake, I think all the mistakes that I can think of off the top of my head sort of come from that one basic premise of trying to simply move your physical data center infrastructure in the way that you've always done things into the cloud. I see people sort of take their network map that they have currently and then just sort of try and transpose it into a cloud environment. And that's going to carry all the same problems with you that you've always had. I think the big mistake really is not fully understanding and leveraging this new way of thinking and this new way of designing a deployment that will allow you to fully leverage all of the tools and APIs and economies of scale and automation that come to you through your infrastructure as a service provider.
Okay. Which of the security principles you talked about this morning do you implement at Sumo Logic?
Everything. This presentation was built on, my 20 months here at Sumo Logic helping, build and secure this service from the ground up. Everything that I've talked about here comes from, my real-world experience in helping, build and run this deployment.
Do you really think it's possible to build a cloud environment more secure than a data center environment?
Yes. Absolutely. I think, once again, that all of these types of things that I've talked about, all of this automation and all of this scale are things that are very hard to achieve in a data center environment, and that with the right thought and design, you can absolutely achieve in the cloud.
Okay, we have another question. Please describe your staff desktop, laptop security.
So, so as a result of PCI, right, anything that connects to production needs to follow certain security standards, right? So on a desktop level, we have whole disk encryption for everything. We also have two-factor authentication with FIPS 140 compliant key fobs in order for people to access production. We of course have to run, antivirus software, and we of course have to have, timeouts, locking screensavers set to 10 minutes, and those types of things on anything that can connect to production. So our operations team, who's desktops and a couple select laptops are allowed to connect to production, have to rigorously follow those standards of whole disk encryption, strong passwords, two-factor FIPS 140 compliant authentication, and all of those things that you'll find in the major standards like PCI DSS.
Okay. One more question. How can I ensure the transmission of my logs is secure?
So, well, here at Sumo Logic, we have a bit of software that you would run called the collector. And this is a little bit of Java code, which we have tested by a third party, and that takes your data, your log data, compresses it, and then encrypts it, and then sends it over HTTPS back to our service. So that log data is encrypted, before it ever leaves the collector, and goes over an HTTPS tunnel back to our secure deployment in the cloud.
Okay, I think that wraps up our presentation for today. Thanks for joining us. On the screen right now, you can see a couple of next steps. For more information on what Joan covered, there's a white paper on our website you can download. You can email us with any questions or comments about the presentation, and register for our next webinar coming up in early December, Real-Time Insights from Your Machine Data. And if you're interested in registering for Sumo Logic Free, you can visit our website to do that as well. Thanks for joining.